This is yet another question based on vectors, and it is taken from the same place, BGCSE paper 3. Right, and we are going to answer all of these questions using a step-by-step approach. Remember, there are many methods, possible methods that can be used. I am going to use one of those possible logical sequential ways in which we can so do. Alright? You may pause the video when you deem it necessary to so do, or you may return to a previous piece, right? As you may not be able to see the entire question throughout the answering of this question. So, let us begin. The first part asks us to, that's A part 1. Write the column vector for P plus 2 of Q. We know that P is 12, negative 5. We want to add 2 times Q. And Q is negative 6, 5. So we rewrite this vector and then we simplify our second vector. 2 times negative 6 and 2 times 5. 12 minus 12. Negative 5 plus 10. Remember, even when you get 0, you still need to write it. Do not just write 5 alone. A vector is made up of x term, y term. 2 things. X, y. Good? The next part asks for m when mp is equal to mq. M has no value because m cannot be seen anywhere. M has nothing to do with this thing because we have constant terms for both p and q. So m is 0. It has no other value other than 0. So we then look at the modulus of p, or the magnitude. This is where we square root and we find the square of each of the terms. 12, 144, negative 5 times negative 5, the square root, 169. Okay, this one was pretty straightforward. You will get exactly 13 units. You may review these questions on your own for your purposes. Good? Let us look at our quadrilateral. This diagram is going to be used to answer the next 3 questions. My first asked me for AC. Vector AC. Good. So my vector AC will be equal to AB plus BC. AB plus BC. Remember, the 2 inner must be identical. Right? These are my inners. AB is represented by B plus C, so I substitute. And BC is represented by, then you simplify where and if possible. B plus 5B, so we will have 6B plus C. Let us look at our vector DC. DC. So I'm going to be going this way. DC. All right. Right, so again, we're going to use two vectors. We can go DA plus AC, right? DA, AC. Good. What is DA? DA is the opposite of what we see. So remember what I said to you. The two signs now are going to change. 3B becomes a negative and 2C becomes a positive. So we can write negative 3B plus 2C, and AC, we just found AC in our previous part, 6B plus C. Right? All we do now is to connect like terms. Negative 3 plus 6 is positive 3. 2C plus C, right? Sometimes we leave it like this, and then sometimes they'll say, oh, simplify it by doing, right? But they really do not subtract your points anyhow. Good. And so we've answered 1, 2. We need to do one more. We want to write down two geometrical properties of A, B, and D, C. Vectors A, B, and D, C. A, B, and D, C. One of them is that vector A, B is parallel. Vector A, B is parallel to vector D, C. So we need one more. We just found DC, so I'm going to write it in. DC was 3B plus 3C. Look carefully at the other answer. Don't you see that this here is 3 times as much as this one? So AB has to be multiplied by 3 to give me DC. So I can either write 3AB is equal to DC, or I write it the other way, right? 1/3 of this is the other one. 1/3 of DC is equal to AB. All right, and that's it. So we've answered all of them. Good. Thank you for watching. Review where possible. Thank you.